Obesity is often framed as a cosmetic or lifestyle issue, something that affects appearance or self-esteem. But beneath the surface, it plays a far more insidious and far-reaching role, one that directly accelerates the body's aging process at the cellular level. The relationship between obesity and aging isn't just coincidental, it's mutually reinforcing. Obesity doesn't just increase the risk of age-related diseases like diabetes, cancer, and heart disease. It speeds up the very mechanisms of biological aging itself. And once this acceleration begins, it creates a feedback loop. As the body ages faster, it becomes harder to lose weight, harder to maintain energy and mobility, and easier to fall into a cycle of inflammation, disease, and decline. This is a two-way relationship that quietly undermines health from the inside out, long before obvious symptoms appear. At the heart of this process is chronic low-grade inflammation. Excess fat tissue, particularly visceral fat stored around the abdominal organs, is not inert. It functions like an endocrine organ, secreting a cocktail of inflammatory substances called adipokines. These compounds keep the immune system in a state of constant, low-level activation, which over time contributes to tissue damage, insulin resistance, and the progression of diseases typically associated with older age. This chronic inflammation, often called inflammaging, is now recognized as a major driver of premature aging across virtually all organ systems, including the brain, heart, liver, and skin. Oxidative stress is another mechanism through which obesity drives aging. Fat cells, especially when overexpanded, generate an excess of reactive oxygen species, ROS. These unstable molecules damage DNA, proteins, and cell membranes. Under normal conditions, the body has antioxidant systems to neutralize these threats. But in obesity, these systems become overwhelmed, leading to cumulative cellular damage. The result is accelerated wear and tear at the molecular level, which contributes to earlier onset of age-related decline in function, both physically and cognitively. Perhaps most striking is the impact of obesity on telomeres, the protective caps at the ends of chromosomes that shorten as cells divide. Telomere length is widely considered a marker of biological age. The shorter the telomeres, the older the cells behave. Numerous studies have found that individuals with obesity tend to have significantly shorter telomeres than their leaner counterparts, even after accounting for chronological age. This means that obesity is not just associated with the diseases of aging, it is actually pushing the biological clock forward faster than it should be ticking. People with obesity may biologically resemble someone years older than their calendar age, not just in how they look, but in how their organs function and how their cells recover from stress or damage. And this acceleration doesn't just affect longevity, it also affects quality of life. Faster biological aging means more fatigue, reduced mobility, impaired memory, slower healing, and greater vulnerability to infections and environmental toxins. It also means a harder time bouncing back from illness or surgery and a higher likelihood of developing multiple chronic conditions at a younger age. The body becomes more fragile, less adaptive, and more inflamed, creating a foundation for early disability or dependency. Yet here's where the cycle deepens dangerously. The very effects of accelerated aging caused by obesity make it harder to reverse the condition. As metabolism slows, muscle mass declines, and energy decreases, physical activity becomes more difficult and fatigue becomes more constant. Hormonal imbalances worsen insulin resistance, which drives further fat gain. The brain's reward system becomes more sensitive to high-calorie foods and less responsive to normal satiety cues. In other words, obesity and aging feed each other, biologically and behaviorally, in a spiral that becomes increasingly difficult to break the longer it is allowed to continue. But, and this is crucial, this process is not irreversible. While obesity accelerates aging, intentional and sustained lifestyle changes can slow that process down, sometimes dramatically. Weight loss, even modest amounts of 5 to 10% of total body weight, can reduce inflammation, improve insulin sensitivity, and restore more youthful cellular behavior. Exercise, particularly resistance training and aerobic activity, can increase telomere length, reduce oxidative stress, and promote the release of anti-aging compounds like brain-derived neurotrophic factor, BDNF, and growth hormone. Diets rich in antioxidants, fiber, and phytonutrients, like the Mediterranean or whole food plant-based diets, can help reduce the inflammatory burden on the body and repair some of the metabolic damage. Sleep also plays a central role. Poor or irregular sleep increases cortisol and inflammatory markers, disrupts glucose metabolism, and accelerates fat accumulation. Improving sleep hygiene and maintaining a consistent sleep-wake rhythm can have profoundly anti-aging effects, both physically and cognitively. Stress management is similarly essential. Chronic stress fuels overeating, drives cortisol-mediated fat storage, and suppresses immune resilience. Addressing stress through meditation, nature exposure, or social connection reduces the biological damage associated with both obesity and aging. Importantly, this is not just about extending life. It's about extending health span, the number of years lived in good health and full function. No one wants to live longer in a body that feels older than it should. Reversing obesity-induced aging is not just a cosmetic pursuit. It is a fundamental investment in the body's resilience, strength, and independence. Every pound of fat lost, every new muscle gained, every inflammatory marker lowered, pushes back the clock in real, measurable ways. In conclusion, obesity is not just a risk factor for age-related diseases, it is a biological accelerator of aging itself. Through inflammation, oxidative stress, and telomere shortening, excess fat quietly damages the body at the cellular level, making people biologically older than their years. But while the process is powerful, it is not beyond control. With knowledge, intention, and consistent effort, the body can repair and recover. Aging may be inevitable, but how fast and how hard it hits is still within our power to change.